Hi, I am Garan Grijalva, studying in Sri Venkateswara College of Engineering, Bengaluru, and I belong to Devo section and brand CSE AI. Subject Applied Chemistry for CSE stream. Subject code BCHES 202. Today I'm going to talk about sensors. Introduction: the basic function of a sensor system, which is fundamental and main element of a measurement and control system, is to measure change in a property or change in a state of the analyte. It employs the sensing element which interacts chemically or physically with the analyte and its surrounding atmosphere, which causes interruption or initiation of a signal. It is then followed by the use of a transductant element to convert a physical or chemical measurement into a related parameter that can be later converted using microprocessor and analog to digital converted to process to output the data. Basic definition: a sensor is a device that produces an output signal for the purpose of detecting a physical phenomena. In the broadest definition, a sensor is a device, module, machine or subsystem that detects events or changes in its environment and sends the information to other electronics, frequently a computer processor. Sensors are used in everyday objects such as touch-sensitive elevator buttons, static sensors, and lamps, which dim or brighten by touching the base, and in innumerable applications of which most people are never aware. Classifications of sensors: the sensing system contains three basic components, namely sensing element, transducer, and the output unit. Considering energy stimulation provided by input signal and need of external energy source, sensors can be classified as passive and active sensors. The, op- the operation of a passive sensor relies on the energy stimulated by input signals without need of any external energy source. Applications: in present era, sensors are being the most almost very industry for automation and processes controls. In addition, electronics, aviation, agriculture, and biomedical field are increasingly accepting the use of sensors. Besides, it is logical to classify the sensors based on the type of the primary interaction. Change of state or property of analyte can be radiant, mechanical, electrical, thermal, magnetic, or chemical. The change in any mentioned discipline can be useful to measure more than one property by using empirical formulas and different type of transducers. For example, mechanical change measured by sensing element can occur due to acoustic waves and also due to applied pressure or load. In this case, measuring mechanical change can be useful to obtain information on acoustic pressure and frequency detection or mechanical structure. Optical sensors. Optical sensors have wide range of application because of the way physical properties can be translated into optical working principles. The optical parameters like wavelength, spectrum of light source for various temperature, diffraction in different mediums, frequency and speed makes it suitable for many applications in automobile, biomedical, aviation, manufacturing and quality control application. In year 2000, study done by Bedell and Slow et al. Shows poly-PDMS binder films with luminous di-platinum-2 and dispersed or dissolved on its surface has a potential to follow as sensors to detect oxygen. After the improvement in approach over the year, fabricated the sensor surface with micropillar arrays made for same dye and binder material, which increases the sensitivity of the sensor over 30-fold than conventional PT-TFPP oxygen sensors. Chemical sensors, a molecular recognition system, and the main two basic components of any chemical sensor. The sensing surface, also known as receptors, and the key element which interact with the analyte molecules. The most common possible interaction between those two can be adsorption, ion exchanging, and liquid to liquid extraction. Due to applicability of this interaction of sensing in various areas, chemical sensors are becoming usual day by day. Analysis of gas composition for environmental observation is one of the common use of chemical sensors. The metal oxide with film sensors in this case have the receptors which transfers the charges to a fro and analyte species in the interest. Among all field of applications, biomedical application might be considered most critical and requires high hand and it deals with crucial measurements which affects the human life. Modern implemented uh, sensors can be measured heat, flow rate, pressure, pressure, electrical and chemical properties inside the living organs. Latest trend involves widely affordable biomedical sensors embedded on the patches and wearable gadgets to monitor heart rate and activity. Monitoring for calories burnt. Initially, the body implantable sensors remained just research restricted because of the size and power supply constraint. In some cases, the modern implantable sensors have capability to measure extremely small quantities. Other type of sensors, apart from need of high accuracy and sensors, advanced in the by micro micro electromechanical systems and nanomechanical systems have forced research to develop miniature sensors to monitor electric devices, and many other type of sensors have mentioned in the discussion above in the topic. Direct sensors have transduced with either or the externally supplied signal with respect to simulated input. In case of hybrid sensors, they need to employ additional transducer to convert stimulated signal into measurable quantity. Usually, a chemical hybrid sensor need to have two transductors where one converts the energy or exothermic reaction into heat and second heat into electrical signal. Considering that the nature of the analytic sensors can be analog or digital. For example, for load or temperature measurement, it is logically to employ transducer that generates analog output for accuracy and wide range. Thank you.